Hello everyone, on this part we have least square regression. Okay, so once the scatter diagram and linear correlation coefficient show that two variables have a linear relation, we then find a linear equation that describes this relation. So one way to find a line that describes the relation is to select 2 points. So selecting 2 points from the data to provide a good fit and to find the equation of the line through these 2 points. So we're going to use algebra for this part using point slope for and slope intercept. Example number 1, using the following sample data. This part, the first row we have x, so it's explanatory variable, and y as response. Part A, find a linear equation that relates x, the explanatory variable, and y, response variable, by selecting 2 points. So we're gonna select 2 points and find the equation based on those 2 points. So I'm choosing to have these 2 and 5.7, and here 6 and 1.9. So I pick 2, 5.7, and 6, 1.9. Then after that, find slope. We can find slope. So showing with m, our slope is equal to y2 minus y1 divided by x2 minus x1. So that is equal to, it doesn't matter which one you choose for x1, y1, which one for x2, y2. So I'm choosing this one for x2, y2, and the first one x1, y1. Okay, so that is 1.9 minus 5.7 divided by, here is 6 minus 2 for x's. That's equal to negative 0.95. So we have negative slope. Now we want to find our line. So step 2. Using point slope form, we have y minus y1 equal to slope multiplied by x minus x1. So y minus, here I had x1, y1, let's have same thing. So y1 is 5.7 equal to, slope is negative 0.95 multiplied by x minus x1 is 2. Okay, so this one was point slope form. Now we want, at the end, we want to have our line the form of slope intercept. So y minus 5.7 equal to, use distributive property here, so negative 0.95 multiplied by x, then negative 0.95 multiplied by negative 2 is positive 1.9. Now add 5.7. So y is equal to negative 0.95x plus 7.6. So here is our line. And what we have on this part, this is our slope. And based on that, y-intercept is 7.6. Now part B, graph the equation on the scatter diagram. Using calculator, we should enter all these x and y. So press that. We have this part, choose edit, enter. And then enter all data that you have for x into L1, those that are for y into L2. Okay, we have these points. Now we want to graph, so again, exactly same as the previous part. Press second. Then after that, on top of that, we have y equal to. We have this one, choosing the first one, enter. Now I should have, so here is off, we should choose that one, here is on. We're choosing that one. Now we have on, and I want to have scatter diagrams of choosing the first one. Here we have L1, L2, so that is great. And I'm choosing the first one here. So I can use that one to graph. And color here doesn't matter because we only have one group. Okay, then after that, press window. It's on the first row on top of your calculator. Since the smallest number for x was 0, I chose to have -1. And the greatest one, based on the table that we have, is 6, so I'm choosing to have 8. So this is our interval -1 up to 8. This way, all the points that we have on that table, we can have all those here in that interval. So we have 0, 2, 3, 5, 6, 6. So those numbers are between -1 and 8. Now for y, we have the smallest number we have is 1.9, and the largest one is 5.8. Obviously, those numbers are between 1 and 7. Then after this, press graph. For example, this one is 0, 5.8. I have exactly that one here, but I draw a straight line to show that we have these points on this straight line. That point is to 5.7, and here is 6, 1.9. These 2 points that I had in the first part. Now part C, use the equation to predict y if x equal to 3. So using this one, to find y, substitute x equal to 3. So y is equal to 4.75. This is what we predict. Now next page, the difference between the observed value of y and the predicted value of y is the error or residual. What is that? Okay, here we had for what we got here was for x we had 3 and y we have 4.75. So this was our point here. But based on this table, what is this one? So here we have 3, 5.2. This is what is observed. So the difference between observed and predicted is error or residual. Okay. So it's observed, predicted. Based on our graph, here we have that point as 3, 5.2. So that is 3 and 5.2, and the other one 3, 4.75. So the difference between these two, okay, 3, 5.2 is that one, and that is 3, 4.75. So this is observed, this is predicted. Now finding the difference between these two is this number, 0.45, which is our error, and that we call that residual. Okay, so for predicted we had when x was 3, y is, we got this number for y. So we had this point or the pair. And from table, observed is for x equals to 3, we have y equal to 5.2. So the point on this part was 3, 5.2. So we can compare these two. So comparing observed and predicted. And determine if they are above or below average. So here in this case, the observed value is above average. because here observed with y is 5.2, and that is larger than what we have here for predicted 4.75. So observed value is above our average. Okay, next part, least square regression line. What is that? The least square regression line is a line that minimizes the sum of the square errors or residuals. So this minimizes our residual. This line minimizes the sum of squared vertical distance between the observed values of y and those predicted by the line y hat. So we use y hat for that. We represent this as minimize the sum of residuals. Okay, let's see what that is. The least square regression line showing with y hat. So here I have that also showing with y hat. And what that is exactly same as having slope-intercept form. So this is B1. That is the slope. So here is our slope, is B1. And what is that part is our y-intercept. Y-intercept is B0, or we can say, okay, x is equal to 0 and y is equal to B0. Okay, once again, x bar is our sample mean, and this x is the sample standard deviation of the explanatory variable. And also y hat is sample mean, and sy is sample standard deviation of the response variable y. That's why we use y here, because that is for response, and here we use x, because that is for explanatory, showing with x. Okay, now example, using the drilling data, part A, find the least square regression line. So first, using TI-84, we should enter all these data. So press Style, Edit, Enter. And after that, enter all these data into L1, L2. So these are our data. And after that, press Start. Choosing this one to calculate, and scroll down to choose number 4, linear regression. Enter. Now here I have L3, L4. I should have L1, L2. So changing the first one to L1 by pressing second 1. And instead of L4, now press second 2. Now I have L1, L2. And enter, enter, enter. So here is what we have. Y equal to ax plus b. A is slope, b is y-intercept. So our slope is 0.01155. I want to round that to 0.0116. And here y-intercept 5.5273. So I'm rounding that one too. And here our R, or correlation coefficient, is 0.7728. Okay, so using TI-84, I got the answer for this square regression line. This is equal to 0.0116. So this was our slope multiplied by x plus 5.5273. So this is y-intercept. So our y-intercept is 0 for x and y is 5.5273. And here is slope. So once again, for the equation of the least square regression, we use a y hat. And here it asks us to find least square regression line. So showing with y hat. Now part B, predict the iterative time of iterating starts at 130. So let's see what observed is for that point. Here is what we have based on this table. X is 130 and y is 6.93. So this one is observed. Now here we want to predict based on this point 130 finding y. So let x equal to 130 and y hat is equal to, our line is here from part A. So multiply by 130. Then plus 5.5273. That is equal to 7.035. So this is predicted. Now part C, determine the residual. What that means, finding the difference between this predicted and observed. Determine residual for the predicted value found in part B. Is the observed reading time at 130 feet above average or below average among all the reading times, beginning at the depth of 130 feet. So from previous part, we know predicted is 7.035 and observed from table as 6.93. So is this one, 6.93. Now find the residual. Is the difference between these two. So observed minus predicted. So that is equal to negative 0.105. What that means, since we have negative number, this means the observed reading, obviously this is lower than what we have here or predicted. That's why it's below average. Part D, draw the least square regression line on the scatter diagram of the data. Okay, so here again, press second, then y equal to, choosing the first one plot. Okay, so that one, we want to have that one on. Okay, so now choosing window to enter all these numbers. So I'm choosing to have the minimum value for x10, max 220 based on the numbers that we have on the first column for x's, because the smallest number we have for x is 35. I'm choosing to have 10, and the largest one is 190, so I'm choosing to have 220. So obviously all of these numbers on the first column are in this interval. Now for y, I chose to have the minimum value 3 and max 10, because here on the second column, the smallest number we have is 5.88, and the largest one is 7.9. Obviously, those numbers are in this interval, so all of them. Okay, so this was our window, and then on this part, I want to also draw a straight line. So using this calculator, I want to draw a straight line. Let's see what that is, how we can draw it. So on the first row on top of your TI-84 calculator, we have y equal to. So and on top of that, we have stat plot F1. So press that one, y equal to. Then enter what you got from port A. What was your least square regression line? So you should enter all these. This is the slope multiply. So using that one, multiply by x plus our y-intercept. After you enter this one, and make sure you have plot 1, because on the first step we chose to have this one, plot 1, and that is on. So same thing here, choosing the first one. And after that, we can graph. So here is our line. So here we have straight line, that is a straight line. And we have all these points. Okay, so this is exactly what I got on calculator. Now next page, interpret the slope and y-intercept of the least square regression line. Okay, so we already know that what the slope is. In algebra, we learned that the definition of slope is right over wrong, or tangent y divided by tangent x. Here we use y2 minus y1, and this is x2 minus x1 denominator. If a line has a slope 2 over 3, then if x increases by, what that means is if x increases by 3, because here in denominator we have the tangent x. So if that increases by 3, y will increase by positive 2, because we have both of these are positive number. That's why we have increasing. Or if the slope of the line is -4, so that is -4 divided by 1. Then if x increases by 1, y will decrease by 4, because this on top is negative number. That's why it's decreasing. In the drilling example, the slope of the regression line is 0.0116. So this is what we had for slope on this example drilling data. For each additional foot of depth we start drilling, the time drill 5 feet increases by, that is slope as this one, but that is it's 0.0116 over 1. So it increases by 0.0116 minutes to an average. Once again, it's increasing because we have positive number. Okay, interpretation of the y-intercept. In general, y-intercept, we interpret the y-intercept as being the value of the response variable. So y is always our response variable and x is explanatory. So here again we have same thing. When the value of the explanatory variable is 0, so when x is 0, to interpret the y-intercept, so we already know that for y-intercept we have 0, x equal to 0, and we need to find y. So this is exactly that one. So x is 0. To interpret the y-intercept, we must first ask two questions. So is 0 a reasonable value for the explanatory variable? And the second one is, do any observations near x equal to 0 exist in the data set? Okay, these are because to have y-intercept, we should have that x equal to 0. If not, we're not able to have that y-intercept. That's why we should ask these to see if do we have that explanatory variable equal to 0 or close to 0. Okay, if the answer to either of these questions is no, we do not interpret the y-intercept, so we're not going to have y-intercept. In the drilling example, the y-intercept of the regression line is 5.5273 was this number here. And to interpret the y-intercept, we must first ask these two questions. Is 0 a reasonable value for the explanatory variable? Yes, because 0 fit would represent starting at ground level. So the answer is yes. So this representing because based on the table here we have x was for depth, and when x is equal to 0, what that means starting point is at ground level. Do any observations near x equal to 0 exist in the data set? So the closest one that we have here to 0 is this point, is 35. So yes. So this is relatively close to 0. Therefore, the time to drill when beginning at ground level is 5.5273. how we got that is y hat was equal to 0.0116 multiplied by x, so this is slope, plus here is y-intercept. That is equal to so starting point here is ground level. We have x is 0. Okay, so that is equal to 5.5273. Okay, now next page, predictions when there is no linear relation. Remember, for having linear relation, we should compare absolute value of correlation coefficient if that one was greater than what we have for critical value using the table on page number 4 from previous section. If that one was greater than critical value, then we can say we do have linear relation. If not, there is no linear relation. And so when the correlation coefficient indicates no linear relation between the explanatory and response variables, the scatter diagram indicates no relation at all between the variables, then we use the mean value of the response variable. So when we have no linear relation, instead of predicted value, we're going to use a mean. So we use mean value of the response variable. So this is response. That's why we should use y. Okay, I'll be writing that part. So that is y hat. This one is y bar. So when there is no linear relation, we're going to use mean instead. So mean of a response variable as a predicted value. So this is predicted value. And here this one is mean of response. Example number 3. So on the spot, we have 10 randomly selected chief executive officers because we have 10 numbers here. So that's why we have our sample size is equal to 10. So in the company's stock performance in 2009. So this is company's stock performance. Now, what would be the predicted stock return for a company whose CEO made $15 million? What would be the predicted stock return for a company when CEO, chief executive officer, made $25 million? So the first column here we have, this is X, our explanatory variable, and here, so what the outcome is our stock return based on what the question is. We know that is our response is Y. So first, we should find what the correlation coefficient is. So always identify the correlation coefficient. R. Then determine if the linear relation exists. Okay, so we should enter all this data into calculator. So press that, choose edit, enter, and after that enter all these numbers that you have in first and second column into L1, L2. So we have these data. Now we want to find correlation coefficient, so press that, calculate, and then scroll down to number 4, linear regression. We have this one, press enter. Okay, see, and that one I have L2. Here is L2. I should fix that one. X is L1, is not L2. So press second, 1. Now I have L1, L2. Then enter. Enter. So here is y equal to ax plus b. Our slope is negative 0.9428, and y-intercept 33.2350, and our correlation coefficient, we need that one. R is negative 0.206. I'm rounding that to this number. Okay, so R, we rounded it to negative 0.206. Then after that, we should find what critical value is. Here, sample size is 10. So finding that 10, this n is equal to 10. Critical value is this number. We have 0.632. Now compare that critical value with absolute value of R. So absolute value of R is positive 0.206. Next step, we should see if this one is greater than critical value that we got here is 0.632. Okay, this is not greater than that one. What that means, no linear relation. Therefore, we should use the sample mean for response variable instead of this predicted value. And the next step, we should find what that y bar is. So here we have our x's X bar. Here we need Y bar. We already have our data into calculator, so stat, edit, you entered all this data. So to find X bar, press stat. Choosing that one, number 1. So we have this. Here is based on L2. So I shouldn't have L1 here, I should have L2. But let's find both of these. First I'm gonna find X bar. We don't need that one, but let's find it. So here X bar is 16.883. Now again repeat that. Now I wanna find Y bar, which is based on second column, so I should have L2 instead. So press second, 2. Now I have L2. And after that you can press enter, enter, enter. So Y bar is, so that is actually Y. So Y bar is equal to 17.317. That was, I'm not going to use this one, but I'm writing it. We need this part, 17.317. So this is equal to, okay, I want to run this. To 17.3. And see, all these are in percent. So here is percent. So what was the question? We need to answer that part. So our conclusion is we predict Pol Pot executive officers making $15 million and $25 million will have an average stock return of 17.3. So this is based on what we got here. Okay, now example number 4. The following data represent the number of licensed drivers in various age groups. Here we have X, here is Y for males, and same thing for females. Here is the first column for this group is X, and here is Y, which is response variable. Find the least square regression line for each group for males and females. So we need to enter all these data into TI-84. So these are our data. I entered L1, L2 for males and L3, L4 for females. Then after that, stat, calculate, scroll down to choose linear regression. You should have L1, L2 because this is based on the first two columns to find regression line for males. And here is what we got for our line. Slope is this number, y-intercept is here, and correlation coefficient is this one. We had this part before. And for females, same thing. Stat, calculate, scroll down, number 4. So we have number 4, enter. Now instead of L1, L2, you should have L3, L4. So press second. Then for L3, you need to enter 3. So second, 3. And second, 4, you have L4. Then enter. Here is what we have for female. Slope is that number, y-intercept, and correlation coefficient. Okay, so for male, this is equal to 0.3428. I rounded that. So that was slope. I'm using equal to. We rounded it, but that's fine. We can use equal to here. So 0.4488. So this was slope, and here is y-intercept. And for female, is 0.1045 times x plus 514.1520. And for this one, it didn't ask us, but I'm writing it. So R for that group was 0.883. This was male. And for female, 0.836. Okay, part B, interpret the slope of the least square regression line for each gender. If appropriate, how might an insurance company use this information? Okay, here for males, and on the side, I'm writing for females. So based on what slope is 0.3428 over 1. And here is 0.1045 over 1. So what that means, if the number of male drivers increases because we have a positive number, increases by 1,000, is here we have thousands. Then crashes increases point, what we have on top, 0.3428 thousand on average. Okay, same thing for the sport. So if the number of female drivers increases by here we have 1,000. Then crashes increases, what we have on top is 0.1045 thousand on average. So how might an insurance company use this information? So our conclusion is insurance company may have higher rates for males. And that is because here slope for males is larger than what we have for females. So that number is greater than this number here for females. Part C was the number of fatal accidents for this group 21 to 24-year-old males above or below average. And the next one is what's the number of fatal accidents for males greater than 74 years old above or below average. How might an insurance company use this information? Does the same relationship hold for females? So we're gonna work for both of these, males and females. So first we have this group is 21 to 24. We have the sport 21 to 24X is this number 6,941, and Y is 5,016. This is observed. So that is observed. Here we want to find predicted and then comparing predicted and observed and see what the result is, if the answer is above or below. X is from table, we have 6,941. Finding what predicted is y hat is equal to, based on our line here on top, instead of x, we have 6,941. We find predicted value. So y hat is equal to this number, and we already know that observed is 5016. Since observed value 5016 is greater than predicted value, this is above average, now for each group greater than 74, okay, this should be greater than. X is this one and y is here. So this is observed. So we have x 4803. Exactly same as that part. Finding predicted, that is equal to. Now instead of x, here we had that number. Now instead of x, we have this number. So that is equal to 2644.9, and observed from table, that was equal to 2022. Now compare these two. Since observed is less than predicted, this is below average. So these two were for male, now female. Again, age group is 21 to 24. And here we have these for 21 to 24, and this part is for greater than 74. So X is 6,816. So y hat is equal to, using this line, multiply by this x that is equal to 1226.4. And from table observed is 1531. So based on these two, predicted and observed, since observed is greater than the number that we got for predicted, this is above average, the same thing. Now for this age group, X is 5,375. So exactly same as this part, finding predicted. Now instead of X, we have this number 5,375 here on that part. Find Y hat. And observe from table is 980. Now compare these two, since observed is less than predicted. See, if you notice, I always started with observed. So observed first for all of these, and then on right side I have predicted, and then see if do you have greater than or less than. When you have greater than, that is above, and when it's less than, it's below. So here again we have below average. Okay, so we answered the first two questions. Now, how might an insurance company use this information? The insurance company may have higher rates for younger drivers. because this one, for this age group, we had above average, but this age group was below average. So obviously, they're gonna have higher rates for this group 21 to 24. Okay, we finished this section.